பார்ட்டிசிபெண்ட் நம்ம தான் ஹோஸ்ட் பாருங்க. ஹோஸ்ட் கரெக்டாக பார்ட்டிசிபெண்ட் நம்ம லிங்க் எதுக்கு கொடுத்து போனீங்க?
லிங்க் வந்து
அதான் கேட்குறேன். லிங்க் இப்போ லிங்க் இந்த லிங்க்ல போங்க. வராங்களா? வந்துட்டாங்க. அவ்வளோதான். நான் ஒரு கோஹோஸ்டாக மாற்றிருந்தேன் சுப்பிரமணியன் சார். மோரில் போயிட்டு கோஹோஸ்ட் இருக்கா எங்க? இல்லை நம்ம அட்மிட்டால் கொடுத்துட்டீங்களா? அவ்வளோதான். சூப்பர். இந்த கைராசிங்க வருவாங்க. ஃபஸ்ட் செஷனில் 12 பேர் தாங்க. கைராசி நினைக்கிறேன். டக்குன்னு வர முடியும் 1 hour. ஏன்னா பாஸ்வேர்ட் தப்புன்னு நினைக்காம ஜூம்
சரி, இதை மியூட் பண்ணணுமே.
No problem. யார் அவங்க மேடம்? ஓகே ஓகே ஓகே. இவங்க நான் இது ஷீலா மேடம் இருக்கேன். சரி ஓகே. ஓகே ஓகே. எத்தனை பேர் இருந்தாங்க முன்னாடி?
Sir, shall we start the session?
Yes, madam. Okay. Shall I start presenting?
Sir?
Shall I start presenting, madam? Hello?
Sir? Sir, is it possible to share the screen?
Madam, I have no options here.
Hello, sir?
Madam,
Afternoon,
one
sir.
second. Yes, madam, 1 second, 1 second.
Is it okay?
Present பண்றேன்.
Can you able to see the screen? Hello?
சார் வந்து சார் ஸ்க்ரீன் ஷேர் ஆகுது. வந்துருச்சு சார். ஓகே சார்.
होम सुनो है ना पाटील सर बोलते हैं पॉलिटेक्निक में काय झालं ऍडमिशन तुम्ही फॉर्म भरला का ऑनलाइन फॉर्म भरला
Hello?
कन्फर्म केलाय का
Am I audible here? Am I audible?
Yeah, it's audible, sir. It can start now.
Okay, now it is audible now.
Yeah, it's audible, sir.
Sir, audible, sir.
Okay, thank you very much, sir. Artificial intelligence. So
Shawan ஒருத்தர் அவர் மியூட் பண்ணுங்க.
sorry, there is a lot of interruption in between, so I just wanted to mute and I have muted all. Artificial intelligence is the base for the machine learning. The next level is the machine learning. The root will be the artificial intelligence. Basically, what is intelligence? Intelligence is behaving intelligently and acting according to the environment and acting according to the environment and ability to learn and ability to solve the problems and ability to um, react to the situations and all those things. So artificial intelligence is nothing but when we talk about the computers here, uh, making the computers intelligent in an artificial way. So that is the basic idea here. Um, Making the computers intelligent so that they can act intelligently. So how to make the computers to act intelligently? So what are all the various algorithms, and we can make the computers to think and to act according to the situation or react to the environment and perceive the environment and try to solve the problems and all those things. And it's simply, as we can say that, how as humans work, face the um, real world, we are making the computer to face the real world and provide the solution for that. So that is artificial intelligence. So intelligence, as we know, is the ability to acquire and apply the knowledge. So acquiring is the knowledge is learning through the experience, no? Learning through the experience and store in the database, and you apply that experience and then behave according to that situation, applying the knowledge. So that is the knowledge is the information acquired through experience. So experience is the knowledge gained through the exposure or the training or various set of activities that the system that faces. Summing up the terms, we get artificial intelligence as the copy of something natural, so which is capable of acquiring and applying the information it has gained through exposure. So it acquires the information and then it applies the information and then it exposes the information or it exhibits the information based upon the situation which it is needed. So that is the basic definitions in artificial intelligence. And intelligence is composed of, you know, what are all the various things that is composed. One is reasoning. Reasoning is what is the reason behind it. Anything that we see or perceive, then we have to reason, uh, justify ourselves for why it is like that and for what it is like that and all those things. That is the reason. Everything we ask question. Everything we ask question, whatever we perceive in the environment. So that is the reasoning. And the learning. How do we learn? How do we learn? So by making a move, what we learn from that outcome. By making a move, how do we learn and what we acquire in that particular environment. So that is learning. And how to solve the problem. How to solve the problem is the problem solving method. That means for given a problem or given a set of problems, and how do we find the solutions for that given problem is the problem solving. Perception is perceiving the environment through the sensors. So here the system, we integrate the sensors to the system and we perceive the input, maybe input, and then based upon the input that is collected and the system, we are making the system to react to that. So that is perception. And the linguistic intelligence. Linguistic, simply linguistic is nothing but the language intelligence. So maybe any language or the communication, the mode of communication we use is the linguistic intelligence. So what is the modulation that we use for that particular language, and what is the grammar and what is the meaning of that, and so all those things. What is the syntax and what is the semantics of that. So everything that is associated with the linguistic is the linguistic intelligence. So these are all the various activity or intelligence that we can talk about for the human, and how we are incorporating those intelligence to the machine. So what are all the various tools that are used in the artificial intelligence or the search engine, search tool, mathematical optimization. So the logics, that is for a way of understanding by the system. So logics, methods based on the probability and economics. Probability is the possibility of failure or possibility of getting success. It is a probability, and the economics. So artificial intelligence field draws upon the computer science mathematics. So it takes everything. So computer science, it takes the in scientific inventions from the computer science and in mathematical modeling, and it takes the psychological activity of of the humans. We apply the psychology and we apply the linguistics and the philosophy, the artificial neural networks. So we build artificial neural networks based upon the neuroscience, then artificial psychology, and many others. Right? So why need for the artificial intelligence? To create expert system, we exhibit intelligent behavior with the capability to learn, demonstrate, explain, and advise its users. That's all. So when we take an example, when we are playing games in the system, right? So how do the system wins over us? So it all depends on the various models or the various labels or the various inputs that we have given to the system, right? And based upon that, the more the system reacted to the opponent party who is playing. So that is the creating the expert system. Expert system, nothing but a knowledgeable system or the expert which is having the highest knowledge or just having the highest knowledge. Based upon the knowledge with the database that it is having, it exhibits the behavior according to that. So when you have in giving the lesser knowledge, and probably you have more chance of winning the games. So exhibiting the intelligent behavior with the capability to learn, demonstrate, or demonstrate. What do you mean by demonstration? Demonstration, nothing but something you request for a problem and uh, something you request for the problem and the system trying to provide the solution and explain and advise its users. Okay, so helping machines find the solution to complex problems like humans do, and applying them as algorithms in the computer-friendly manner. Right. So providing the solutions for the complex problem uh, and by the help of the algorithms that is built with the system and in a friendly manner. So that is the basic idea of the artificial intelligence, right? And applications of artificial intelligence where we apply. So in general, in NLP, natural language processing, uh, gaming, speech recognition, then vision system, healthcare, automotive. These are the major areas or some of the areas we apply the applications of the artificial intelligence.
క్లాస్ చెప్పటం అయిపోయిందా అయిపోయిందమ్మా ఉచ్చకి తీసుకెళ్తావా ఒకసారి మా ఉచ్చకి తీసుకెళ్తావా వస్తావా
I think someone.
అమ్మ ఉచ్చకి
So, so what artificial intelligence? So artificial intelligence is a system composed of an agent and its environment, right? So agent is the one which perceives and then which collects the information from the environment, and then that is the two things. So one is an agent which collects the information and its environment. So the system is comprising of both the agent and its environment. So an agent is nothing but a human or a robot or any sensor or a camera or something like that. It is senses from the environment, is anything that can perceive its environment through sensors and acts upon that environment through the effectuators. Effectuators are nothing but the effect in which the conversions are exhibited. Effects in which the conversions are exhibited is called effectors, or it is intelligent agents must be able to set goals and achieve them. So what is an agent? Agent is nothing but which something gives, provides the solutions, right? And it must, before achieving them, I mean, what is the problem and what is the goal? What is the outcome of each problem? It must study, it must understand it, and then it has to set the goals, and then it has to, what do you mean by goals? Goals are nothing but the set of the desirable attributes which is required for providing the solution. Right? The intelligent agents must be able to set goals and how they achieve them. And natural language processing gives machine the ability to read and understand human languages, information retrieval, text mining, question answering, and the machine translation. Right? So it understands the human language. So probably maybe in the form of the sound or maybe in the form of the text, how it synthesizes and then it manipulates and then it provide the answers and provide the solutions. Right? So that is able to read and understand the human language and text mining, everything. So like as you can see how the Google is using all the machine learning algorithms and the artificial intelligence technique, right? Machine perception is the ability to use input from the sensors, right? How machine is perceive the input from the environment. So from the environment, how does it perceive? It perceives through the sensors, with cameras, microphones, sensors, so things like that, and to deduce the aspects of the world. So that is deduce the aspects of concepts such as game theory, decision theory, necessitate that an agent be able to detect and model human emotions, right? So what is the objective of artificial intelligence research? So basically, the reasoning, as I said that the reasoning or the questioning and finding of the solution, knowledge representation, various methods used for categorization. There is a method that is used for categorization and identifying and or identifying the solution for the given particular problem. And planning. Planning is something that a desirable problem. I mean, a plan for providing the solution. Planning providing a solution. Learning from the environment. Learning from the environment. So learning like that. So natural language processing, perception, and ability to move and manipulate the objects. For example, it is used in the robots. It is perceived and it moves according to the, or finding the solutions, something like that, right? Perception and the ability to move and manipulate the objects. So general intelligence approaches includes the statistical methods. What is the statistics? Statistics is nothing but something, the data which is already available. Approaches statistical method is nothing but the methods which has the data, pre-set up data that is available, and based upon the data and it machine reads and then it provides solution. What is the next? For example, based upon the climatic conditions, based upon the previous history, we can able to predict the stock market. We can able to predict the stock market. We can able to predict the for example, in Amazon, when you see, we can able to predict how many number of users will be purchasing the particular item, right? So these are all some of the statistics. So many tools, that is computational intelligence and traditional symbolic AI. Many tools are used in artificial intelligence, including versions of search and mathematical optimization, artificial neural network, the search and or mathematical optimization, providing or optimizing the solution using a mathematical formulas or mathematical scientific way, right? Searching is so with the least number of moves, providing the best solutions, right? So that is the search and mathematical options optimization. Artificial neural networks, nothing but what is a neural network or artificial neural networks are neurons, as how our brain, in our brain, the neurons are the core part for analyzing or for studying and then reacting to the environment. So like that, artificial neural network is also plays a vital role. It is something like simulating like our brain. Simulating like our brain. Artificial neural network, it simulates like our brain, and then and what our brain does. So it studies, learns, and reacts. Similarly, the artificial neural network is nothing but the machine brain. Right? So methods based on statistics, probability, and economics. Right. So, and as I said that earlier, it includes the computer science, information engineering, that is knowledge or the databases, then mathematics, psychology, linguistics, philosophy, and many other fields. Right. What are the challenges of the AI? The overall research goal of the artificial intelligence is to create technology that allows computer and machine to function in an intelligent manner. Right? So the general problem of simulating has been broken down to various sub-problems, and the sub-problems in order to learn by the machine very easily. So these consist of the particular capabilities that researchers expect an intelligent systems to display. So reasoning and problem solving. So problem solving refers to the cognition processing. Cognition is nothing but the analytical or the thinking ability of the humans is directly mapped with the system or the computer. Problem solving refers to the cognitive processing, right? Ability and the aptitude, the aptitude of the machine, the ability, thinking ability of the skills by the machine as directed at achieving a goal, and the problem solver does not initially know the solution methods, right? So that is the um, does not. So when the machine does not knows the solution, then the problem exists when someone has a goal but does not know how to achieve it, right? So there is a problem and someone does not know how to achieve the problems. The problem can be classified as a routine or non-routine, and as well-defined or ill-defined. Well, so it is a mental process in psychology and a computerized process in computer science, right? So psychologically, it follows a mental process and then computerized process in computer science. So well-defined problems is having the specific end goals and clear expected solutions. What we are trying to achieve and what we are trying to find out is called as a well-defined problems, clear-cut ideas. What are all the inputs that we need to consider, and what are the output, and where we start and where we are going to end, all those things. That is a well-defined problem. So next is ill-defined problem. Well-defined problems allow for more initial planning, and then so that you can achieve these solutions very easily, right? So whereas the ill-defined problems uh, do not have the specific starting point or the ending goals or how the solution can be made and all those things, right? So knowledge representation, no, that is a field of artificial intelligence that focuses on designing computer representation that capture information about the world that can be used to solve complex problems. So, knowledge representation is the one branch of the AI, right? So which captures or which acquires the information about the world, and it is able to solve the complex problems. Example, diagnosing medical conditions or having a dialogue in the natural language, right? Knowledge representation. Suppose, for example, you will know that in Google search engine, so one uh, input that we are giving as in the text, in the form of the text, and it analyzes, and then the related the similar searches are being brought to the screen. So knowledge representation incorporates findings from the psychology about how humans solve the problems and represent knowledge in order to design formalities, and that will make complex system easier to design and build. So knowledge representation and reasoning also incorporates finding from logics to automate various kinds of reasoning, such as application of rules or relations of sets and subsets that are associated or related with each other, right? So the examples of knowledge representation formalisms include semantic network or the frame network, frames in the form of the frames, okay? So semantic systems architecture, frames, rules, ontologies. So frames are nothing but a set of related attributes of the frames, as how is something it is similar to that of how database we have. So that is a frame, and the rules, ontologies. The examples of automated reasoning engine includes reference engines, theorem provers, and classifiers. You can see here, right? The entity, the set, whether it is an item, is set in the group or item, whether it's individual or a category. So, right? So, and further classifying or dividing into the abstract or a concrete or the space time. So, like that. So, this is an ontological representation of knowledge as a set of concepts within a domain and the relationship between these concepts. Okay. So, it's a planning. Intelligent agents must be able to set goals and achieve them, right? So they need a way to visualize the future and representation of the state of world and be able to make predictions about how their actions will change it. The planning is something that when we move, so what is the outcome of the move, whether it will be a successful or whether we fail, it is a successful or whether we fail in our attempt. And successful is nothing but how many such more steps is required for acquiring a solution. That means without going back to the starting point, we should be able to find out the solutions. They need a way to visualize the future. Future means whether it is able to find a solution or not. A representation of the state of the world, and can be able to make predictions about how their actions will change it, and will be able to make choices that will increase the uh, finding the solutions. In classical planning problems, the agent can assume that it's the only system acting in the world, allowing the agent to be certain of those consequences into actions. However, if the agent is not only the actor, then it requires that the agent can reason under uncertainty. This calls for an agent that can not only assess its environment and make predictions, but also evaluate its predictions and adapt based on its assessment. So multi-agent planning uses the cooperation and the competition of many agents to achieve a given goal, right? So that is coming to the machine learning, which is the integral part of this session. Now, basically, the machine learning is nothing but learn by the machine itself. That's all. Learning by the machine is machine learning. Simple as that. Machine learning is a field of study that gives computers the capacity or the ability to learn without being explicitly programmed. That means uh, programmed is something we need an algorithm that is incorporated for, um, and based upon the algorithm or the work, your system find out that is the program. A program is nothing but a set of things that we are asking the computers to do. That's all. And so only what you are being asked to do, the system does. Otherwise, it will not do. Right. So whereas in machine learning, it is simply like the humans. Without explicitly programming, your system is capable of um, learning by itself, right? That is the machine learning. So it gives the computer that which makes it more similar to humans, the ability to learn. So on the basis of the nature of the learning, signal or feedback available to the learning system. So basically, the machine learning can be categorized into many types like supervised learning, unsupervised learning, semi-supervised learning, reinforcement learnings, and all those things, right? So once again, machine learning is a study of algorithms, right? So the algorithm, or for what purpose that algorithms is used for improving their performance. Performance is performance of learning, performance of the learning through the experiment. By moving a single step, what the machine learns and how much it learns. And exponentially, the learning procedure or learning process is improved at every steps. So with a minimum number of steps, the machine learns the entire thing what it is supposed to. That is improve their performance at a particular task with some experience. That's all. So optimize a performance criterion using the example data or the past experience. So the given data with a given set of data or with the past experience or how it has learned, the performance criteria, it optimizes role of statistic inference from a sample, right? Role of statistic, what is a statistic? Statistic is nothing but we have the set of data associated on the particular model, right? And based upon that give available data, we conclude that we arrive at a solution, or we try to provide a solution, whether that will happen or not, whether the stock market will or the particular thing will increase or decrease, or it will go loss, or it will give you a profit, whether there will be a probability of the disease or the probability of disease for how many number of people, and due to based upon the various number of parameters like that. The role of computer science. What is the role of computer science in the machine learning? So you give the efficient algorithms, right? Say input. Algorithms are designed to solve the optimization problem and representing and evaluating the model for the inference. So in general, the styles of learning. Now, the data supervised learning, data has been given. Data has the known labels or output, right? So unsupervised, I mean, data as known labels means the known label are given fed as the data, right? And then what the system is expected to produce is also given. So that is supervised. Unsupervised is both is not available. You just provide simply a random data, and from the random data, the system has to study by its own, by the available patterns, and it has to find what uh, the system is going to produce the output. Output is undetermined, the data is also not known, right? We are making the system to learn by itself. So that is one, by the given data itself, and then it produces the output. So that is unsupervised. Semi-supervised is nothing but is a combination of the supervised and the unsupervised mechanism. And where some data will be provided with some labels or some attributes or parameters, and some of the data may not be provided with attributes or some labels. But with the help of these available data, not available data, the system has to uh, give you the solution. All right. So reinforcement. What is mean by reinforcement? Right. Focus on making decision based on the previous experience. Reinforcement. Right. So that means stressing. You are enforcing something to learn by itself with the help of the previous experience, and to improve the policy making with the feedback. So these are the places where it is used to supervise in insurance, writing, fraud detection, and supervise, customer clustering, association, role mining, right? So like that. Supervised learning. It is a type of system in which both input and desired output data are provided. So input is provided, and what is expected out of the system is provided, right? So input and the output data are labeled. So input data is labeled. That means some features or some attributes are also shown to the system, and output data is also shown to the system for classification to provide the learning basis for the future data project. With the help of the label that you are providing to the system as input data and for the output data, and it provides the learning basis for the future data, and the future data processing is based upon the labeled input data and the labeled output data. So that is the supervised learning. So similar to human learning from the experience, right? Or a teacher teaching the student, right? So in other words, supervised learning, the computer is presented as example inputs and the desired outputs given by a teacher, and the goal is to learn a general rule or a common rule uh, that maps inputs to the outputs. That's all. So we provide the input, and we show the output. So if the input matches, if the set of inputs or the attributes matches to the system, and it maps to that. So that is the supervised learning. The training process continues until the more model achieves desired level of accuracy and the training data. So with the help of the um, desired level of accuracy on the training, the training data need to be provided. So some of the examples are image classifications, right? For example, you provide various images like the human images you provide, and the animal images you provide, and you provide the tree images or the fruit images or something like that, and you categorize it. For example, image classification in the human face recognition system, you can consider the face recognition system. What are the features of the face it may contain? Or maybe the face should be in the oval shape or the round shape, and anything more. Apart from that, it should not recognize the face, and it should have the smaller size of the ear and with a dimension like this and like all those things. Image classification. You train with the image labels. Then in future you give a new image expecting the computer will recognize a new object, right? So that is. So a dog. A dog means it should have 4 legs, and each leg should be like a thin stick or something like that. You train it, right? So all those various inputs you provide to the system, right? Finally, after providing all the training and all the parameters and attributes to the system, then you give an image to the system, and then let us wait for the system whether it identifies what is that, right? Or whether based upon the training, whether the system is able to identify exactly. If you have provided the good training for the system, then your system must be able to provide the correct predictions for that. Right. Next one is the market prediction, and using the regression. You train the computer with the historical market data and ask the computer to predict the new price in the future. So right, so that is machine learning. So classification is nothing but a classifying. How do we classify? Based upon the various associated uh, uh, relationship between them. Every day that all time we classify things. Example, crossing the street. Crossing, for example, when you take consider the situation when you cross the street or the cross the road or the cross the bypass, something like that. So we need to be checking whether there any vehicle coming on the left hand side or the right hand side crosses. And if at all it comes, at what rate the vehicle is moving, will be moving in the street, right? So if it, on average, the average speed of the vehicle in this road will be like this. So if at what distance it can be good for us to cross the road, right? How far is it to the other side? How far is it to the other side, right? Like that. So classification is then whether we come out the solution that whether it is safe to work or not. So if it is safe, we can proceed working. Otherwise, we need not have to work. For example, so these are the raw data you can consider. So for example, these are raw data that we are providing. And the supervised learning, we provide with the label for each raw data, right? In the previous slide, you can see these are all the example. So this is one set of data, this is another data, and this is one another data. But basically, we know that this is an apple, this is a red apple, this is a green apple, and this is a banana, a yellow banana, it is a green banana, or something like that. So in order to identify them, it is an red apple, we must indicate the label as the attribute of the property. So it is like oval in shape, and it is green red in color. So all those things. So if it is like this shape, and similarly you conclude this, it is an apple. So the apple might be also green in color. So like that. So when the feature study the feature, so like this, and it is a banana, and this is also a type of a green banana, this is a yellow banana. These are the labeled examples, right? So these are the labels or the inputs that you are giving, right? So and you are showing the data, you have given the input data, and you have given provided with the label, right? So and what you are doing then, the system or the model or predictor is based upon this, the given system will have to predict what is this, whether it is a fruit or whether it is a vegetable, or if in case of the fruit, what is the type of fruit, whether it is a mango, whether it is a jackfruit, whether it's a custard apple, or whether it is an apple, red apple, something like that, right? So this is supervised learning. So it model. So now model predictor. So it will check for the label and it will check for the shape. It's something which is not given, right? And the system will not find out. So we have given only the red and we have given only the green. And in case of this color, then what the system, right? That it is not available. Then system will not predict because the label which is not available here, right? So what about this, right? So which class does this object fall into? Whether it is a fruit or a vegetable. In case of a fruit, so whether it is an apple or it's a banana. So it's this is something unsimilar to what the label of the data that we have already given. So definitely it will not able to identify, right? So what is the problem in classifying the data? So often high dimension of data, hard to put up simple rules. So our dimension, high dimension of data is when the world data is too high, right? And hard to put up the simple rules. So we need the complicated and the complex rules for identifying it. So when you compare, when you take a simple example in the previous case, no, for each set. Um, in the mango you are giving, but the system is unable to find out, right? So you need to give lot of you high dimension of the database, more perspective. You have to provide the labels, right? And how to put up the simple rules. The amount of data is volume of the data is huge. Need automated ways to deal with the data. Use computers data processing, statistical analysis, try to learn patterns from the data. So classifications, applications. Classification is a type of supervised learning, right? So it specifies the class to which data elements belong to and is best used when output has a finite and discrete values, right? So the output is having the finite and with a discrete value. It predicts the class for the input variable as well. So which class it belongs to, whether it belongs to the fruit, whether it belongs to the vegetables, right? So classification. So it is a type of supervised learning. So based upon the given data element, it predicts the class for the input variable as well. There are two types of classification. One is the binomial classification and another is the multi-class classification, right? So classification inputs are divided into two or more classes, right? The learner must produce a model that assigns unseen inputs to one or more multi-level classification, right? So this is typically tackled in a supervised way. So supervised way is nothing but you are providing the data with a label. So right, based upon that label, you can very easily able to categorize. Spam filtering is an example of classification where the inputs are email messages and the classes are the spam or not spam. So spam messages, so these are all the mails that if it comes, then it is a spam. If it contains so and so messages or if it contains advertisement, these are all the spam messages. And if otherwise it is a non-spam messages. So like that, right? So this is the way of a classification. So that is this one and this one. Text classification. Classification of the text based upon the meaning of the text and corresponding meaning or what the system is required to identify. That is the classification of text according to text classification is the process of assigning the tags or categories to the text according to its content. It's one of the fundamental tasks in natural language processing with the broad applications, sentiment analysis, topic labeling, spam detection, and intent detection. So text categorization in multi-class classification. So categorize text document into predefined categories based upon the tags, right? So tags, whether it is a sports, a politics, a science, or it is a living being, non-living beings, a plant, tree, herbs, shrubs, whether it is a water, something like that, right? So that is a multi-class classifications. You can see here, soft tissues on the T-Rex fossils may reveal details about the cells, blood vessels of a dinosaur. So this something talks about the fossils talks about the living beings which had lived some millions of years before, something like that. So this is a class. Another thing is the health. This is a health may be the concern when giving kids a cell phone, right? So this is a category of the text, and out of which it fetches the output like this. And this one, this is another example for this multi-class classification. Right. So face detection. Face detection, you can see discriminating your human faces from non-faces. So something you are putting a dog here, also you are putting a some other animal here, an elephant, which is also having the face, or the tiger is also having a face with the one nose, two eyes, and two ears, and the mouth and the bush like that, mush and everything. So, but whereas the human faces will be, of course, very different from the other faces, right? So you can see it can humans generally they wear specs, they won't wear specs, and it has a oval shape or round shape, and the general in color, right? And it has a mouth, and it has a shade like this, all those things. So these are all some of the labels that are being given, and it is the faces are detected. Signature recognition recognize the signature by the structural similarities, which are difficult to quantify. So, for example, Tony Blair or something, some name you are giving, or Joseph or something like that. So then you have to identify the letter J, or Tony means T, whether the T is a long letter, Blair, something like that. It comes and it identifies the signature recognition system, right? So next one is the unsupervised learning in machine learning. What is unsupervised learning? Unsupervised learning is no labels are given to the learning algorithm, right? No labels. Simply you are asking the system to accept the data, and you are leaving it by the system itself to find out its structure and learn from the given data itself, and it should be able to conclude that one. So that is, no labels are given to the learning, or leaving it on its own to find structure in its input. It is used for clustering population in different groups, right? Different unsupervised learning can be a goal in itself, right? Is discovering the hidden patterns in the data, and then it fetches it, and then it stores it, and based upon the then data which each machine has identified by itself, then it discovers the um, data, I mean new data that is given. It identifies the new data that is given, right? So that is the unsupervised learning clustering. You ask a computer to separate the similar data into clusters. This is essential in research and design. High dimensional visualization is it uses more dimension. That means more volume of data. Use a computer to help us visualize high dimension data and generative models. After a model captures the probability distribution of input data, it will be able to generate more data. This can be very useful to make your classifier more stronger, right? So you can see here. So this is the supervised learning and unsupervised learning. So in the supervised learning, the data in the supervised learning is labeled. It's a labeled elements, and it is round in size, it is blue in color, and is marked like a star or something like that. So this is the supervised learning. Unsupervised learning, it is something they are very closely related to each other. So machine by itself, it identifies. So this is a group, or this is a cluster here, and another this is a cluster. So this is a method by which or you can differentiate between the supervised learning with the help of the label and unsupervised learning without the label, and how the system is distinguishes between, or it categorizes between these two, right? Semi-supervised learning is a problem where you have a large amount of input data and only some of the data is only few data are labeled, and most other data are not labeled. You have the combinations of both the labeled data as well as the unlabeled data. This is called the semi-supervised learning problems. These problems sit in between both supervised and unsupervised. Example, a photo archive where only some of the images are labeled and majority are unlabeled, right? So reinforcement learning, a computer program interacts with the dynamic environment or the changing environment, and in which it must perform a certain role. For example, automated car without the driverless car. So that is a dynamic environment, right? So it is, we cannot provide the input for the car, how it drives, right? So you can expect any time heavy traffic, you can expect any time there is a hump will be there, and any time the car behind your car may hit your collide, right? So the program is provided feedback in terms of rewards and punishment as it navigates its problem space. When it navigates like this, so agent in the environment, agent is responsible. So regression. So regression is also a supervised learning problem, but the outputs are continuous rather than discrete. For example, the predicting the stock price using the historical data. It's also a supervised learning problem, but the outputs are continuous rather than discrete. Here in the regression, the outputs are not discrete, but they are continuous. Here we say stock prices using the historical data. That is continuous. So an example classification regression on the two different data sets is given below. So like this. So clustering is a set of inputs is to be divided into groups. Unlike classification, the groups are not known beforehand, making this typically an unsupervised task. As you can see in the example below, the given data set points have been divided into groups identified by the red colors. One is a blue color and another is a green colors. So like that. So this is a cluster. Cluster is group of the similar objects or a partition, right? So density estimation, a task is to find the distribution of inputs in some space. So what is the density? That means how many number of people are densely, are located in a particular point. The density estimation, how many people are voting for the particular party. So like that. So task is to find the distribution of inputs in some space. So space may be the party like that, and how many number of voters are voted. Dimensionality reduction is simply dimensionality is reducing the dimension, right? Without changing its originality. That's all. It simplifies input by mapping into the lower dimensional space without changing or altering its originality. So topic modeling is a related problem where a program is given a list of human language documents and the task to find out which documents cover the similar topics. So these are all some of the machine learning algorithms, supervised algorithms, linear regression, logistic regression, decision tree, SVM, naive Bayes, KNN, right? So K means random forest, etc. Well, terminologies model is a specific representation learned from the data by applying some machine learning algorithm. So I think these are all some basic things only. I will skip these slides. So we'll go to the one algorithm, that is the K nearest neighbor classification algorithm in the supervised learning. The K nearest neighbor is a simple algorithm that stores all available cases and classifies new case based on the similarity measures, right? All possible. That is, it has the label. And it has something like that, and then it classifies with the help of the label. It identifies whether object or not. So, what are all the nearest point? Human means he should be having an average height of between 4 feet to 7 feet, so like that. So, and he should have two hands, and he must have a face. He must have two legs. So like that, whether it is a male or female, male will be wearing such kind of dresses, and female will be wearing such kind of dresses, like that. So these are all various possible inputs are the labels that we are given to the system, and based upon that, and when the new object is stored, and it identifies what are all the nearest possible labels that is available that could be predicted for this particular new set of new data, and then it arrives a solution, right? So that is the K nearest neighbor. What is the nearest data? It is a simple algorithm that stores all available cases, and classify the new case based upon the similarity. The similarity measures is nothing but what are the uh, uh, based upon the similarity. KNN has been used in the statistical estimation and pattern recognition in the beginning of 1970s and non-parametric techniques. The nearest neighbor classifier. Basic idea: if it walks like a duck, quacks like a duck, then it's probably a duck, right? So like these are all some of the training records. This is a swan and something like that, something like that. So and how it works and various attributes we are storing and similarities that we are storing. So this is having the two leg and the shape is like this, and this is like seems to be like a duck, but it is not duck, but something a different bird and this bird. And no, so these are all the some of each attributes are unique for this. And with having all these attributes and similarities, and when we are trying to provide the new set of data to here, and it will based upon the available inputs or the train the records, then your machine should be able to identify. Distance compute. Computed distance is nothing but the similarities. So similarities only, right? Choose K of the nearest records. So from the available, so these things are dissimilar, and therefore these most of the features or most of the attributes are similar uh, for this, and therefore it chooses the K of the nearest records. So that is the basic example KNN steps is determine K, the number of neighbors to be considered, calculate the distance between the test data and each of the training data. So distance means what is the similarity? That is the distance. Sort the distance and determine the nearest neighbor based on the value of K. Gather the category of K nearest neighbors. Use the majority voting method to determine the class of test data. Right? So, and how the distance are measured? Distance are measured using any of these methods. That is the Euclidean distance, Manhattan distance, and or the Chebyshev distance, or the cosine similarity correlation. Then Mahalanobis distance, or Minkowski distance. So these are all the various distance metrics that are used for calculating. For example, these are all the various attributes for this particular object, and this for the particular object. These are all various attributes, and right. These are the two-dimensional vectors. The majority vote, the nearest neighbor method, the majority vote within the K nearest neighbors are computed this. Right. So a case is classified by majority vote of its neighbors, with the case being assigned to the class most common among its K nearest neighbors measured by the distance. If the K is 1, then the case is simply assigned to the class of the nearest neighbor. If the K is 1, that is very close to it, means then it is simply assigned to the particular class of the nearest neighbor, right? So like this, right? So this is something, this is not this is this these are all the similar things. These are the similar. Hello. Hello, sir.
Hello. Yes, sir. Hello.
Ma'am,
Is my
smart.
Hello.
तुम्हाला नाही लागत तसा
Hello.
जास्त शिजलाय ना पाणी नाही टाकलं उलट मी आज त्याच्यात वीस त्याला शिजव
Hello, sir.
आपलं आपण लेमन लावून जेवून बसायला आपल्याला नेलेली करायला
Hello, sir. Your voice is not audible, sir.
And does this person like computer games? So that means the age is less than 15. If it is less than 15, whether it is yes or no, that's all. Then it is male or female. So this is the decision trees. What are all the notations that are used in the decision trees? The box, it is used to show the choice that manager has to make, and circle is used to show the probability outcome, the letter, lines, the connect outcomes to their choice or the probability outcome. So this is another easy example. What are the common some of the costs in the business school, right? So what are these are the various uh, the tuition fees, rent, food, etc., opportunity, cost of salary, anticipated future earnings. So these are various parameters or an attributes that we need to consider for taking decisions or finding out the decisions. A simple decision tree model will be so like this. So this is the route whether to go to the graduate school to take my MBA or go to work in the real time world. So right. So uh, you have to compute like this. So 2 years 2 years of tuition fees, that is 28,000, 2 years of boardroom fees, that is $20,000, or 2 years of opportunity cost of salary, and $100,000, and total is $1,75,000 plus anticipated 5 year salary after business school is that is $600,000, and choosing the NPV business school is then that is 4 lakhs. So this is so, and when you go to the real work, go to the work in the real world, and what is so, and when you're computing these things, and this is a higher value, and therefore you go to the business school. So that is a simple decision. Based upon the decision, you take the decision, and then you move for study in the graduate school. Okay. So things that can have mystery, future uncertainty. The problems in the decision tree learning is good for instances represented by attribute value pairs and take on the smaller number of discrete values, and which can be extended to real valued numbers and target function as a discrete output values. So what is the duty phase? In each step, make decision which make greatest improvement in whatever you are trying to optimize. Do not backtrack. So whatever you take decisions and move to the next step, you need not have to go to the backtrack, right? So that is the greedy phase, and you find the solution within the best track. So so how does it determine which attribute is best to classify the data? Okay? And so this entropy. Entropy is something that relates to the machine learning with the measure of randomness in information being processed. The higher the entropy, the harder it is to draw any conclusion. So therefore, the closeness of the entropy should be very, the less for finding out. So flipping a coin as an example of the action that provides information that is random. Right? So information, a statistical quantity measuring how well an attribute classifies the data. Calculate the information gain for each attribute and choose the attribute with the greatest information gain and find the conclusion of that. Right? So this is the way. 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 So
right?
So this is an example you can show. Given a collection, yes, containing positive and negative examples of some target concept or the target problem, the entropy is relative to this Boolean classification is computed as minus p plus log of p minus p minus log of p to the base 2. This is a sample of many examples. So how many samples that we are taking? Maybe 10, 5, 15, 100,000, 1 lakh, like that. And positive number of positive examples. P plus is a positive proportion example, and P minus is a proportion of the negative example. Okay. So ID3 gain algorithm determines which single attribute best to classify the training example using the information. For each attribute, we find the gain of S, A of I, H of S. So this is the formula for that. We use the attribute with the greatest information gain as a root, right? From the root, we take the decision trees like that. And this is an algorithm, right? ID3 algorithm. Create a root node for the tree. If all the examples are positive, return the single node with root with the label plus. If all are negative, return the single node with the label. But of course, we will be having the combinations of both the positive and the negative. So from the available positive and the negative, we need to find out the root node. So if the attributes is empty, then return the single node tree root with the label most common. So values of target attributes and examples, otherwise legal. So this is ID3 algorithm. So example is playing tennis. For attributes, we saw the classification. So one is the outlook is one attribute, temperature is another attribute, humidity is another attribute, wind is another attribute, right? So one predict the target attribute binary. The play tennis, yes or no, that's all. So we have provided with the 14 training examples. 9 are positive and 5 is negative. The outlook contains these values. Either it will be sunny, overcast, or rain. The temperature is hot, mild, or cold. Humidity is high or normal. Wind is weak or strong. Right. So we have to arrive, and we are given with the 14 training examples. That is out of which 9 is positive and the 5 is negative. So training examples. So this is a day 1 to day 14 and outlook various attributes. So this is 5 different attributes: outlook, temperature, humidity, wind, with tennis. So outlook is very different. That is a sunny, overcast, and the rain. Temperature is hot, mild, or cold. Humidity high, normal. So like that, weak, strong. Then is yes or no. So based upon this, we are calculating entropy. So here the 14 cases are there, 9 positive cases. So that is yes, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are calculating entropy for all the cases. The number of positive cases is equal to 9 here, and the number of negative cases is equal to 5. That is no other negative cases. So total number of cases is 14 here, D1 to D14. That is day 1 to day 14. And entropy is computed based upon this, and given the value as a 0.940. So we apply this formula here, and you get the value 940. And step 2, loop overall attributes and calculate it again. So attribute equal to outlook. We are taking only the outlook attribute, right? This one. So outlook is D1, D2, that is D8, D9, and once again D11. So right. So only this attribute, that is sunny attribute you are taking. So sunny. So loop over values outlook. Outlook is sunny. Number of positive is this no. Positive is yes. Negative is 3. That is no is 1, 2, and here D8 is no. And D9 and D11 is alone yes. So number of positive is 2 out of 5. So therefore it is computed. So and the value is 0.971 here. So when you're taking it overcast, a number of positive, you take only the overcast. 1, 2, 3, 4. Out of the 4, total number of positive is 4, and because all the overcast is yes, you can see it. 1 yes, 2, and overcast is yes here, and overcast is yes here. So total number of positive is 4 and negative is 0, and total number of cases is 4, and therefore compute and it is the value is 0.0. Right? So, and from the outlook, you come out with the calculation. That is outlook is rain. Now you take previously you take a sunny and that is right, and sunny and overcast, and now we're computing for the rain. So right. So from this you arrive. So overcast is equal to 0, and for sunny equal to 0.71, and for rain equal to 0.97. So you are calculating the information gain for the attribute using this formula as I showed here. Gain. So this formula you are computing here, and then gain is to yes outlook. So taking the particular attribute outlook here, HRS like this, and then gain outlook is finally you arrive this value, that is 0.246. And similarly, attribute you take the temperature. Previously, we are using the outlook attribute, and here you are taking the temperature attribute, and you are repeating the same process for all the three, and you are arriving at the solution. So like this. And finally, again, you are arriving the value of 0.029. And for the humidity attribute, you're computing the same formula, and you are arriving equal to 0.985, and here is 0.9 the high, and for this value for the low. And this gain that you are computing, and for the wind similarly like this, and this is for the gain wind or the gain you are computing. And finally, the attribute with the greatest information gain is, you can see here, 0.246. Other things are for outlook only the more, and for humidity, temperature, wind attribute, it is very less compared to. Therefore, outlook is a root node of the tree. When the gain value is more comparing with the temperature, wind, and humidity, and that will be the root node. So based upon the outlook, the decision is derived. So outlook is this, right? Outlook is a root node. Sunny, overcast, and rain, right? And what, of course, this one D1, D2, D8, D9, right? This is what attribute it belongs to. You can say is humidity, temperature, and wind. So humidity will be selected, right? In comparison. So resulting decision tree will be this one, right? I think you can go through these slides here and here. And these other issues in the decision tree. We are running out of the time. This is the overfitting, and these are related issues in the decision tree. I will skip these slides, and due to the time constraint, this I'm skipping this unsupervised learning, where I using the k-means clustering unsupervised learning. That's all. Thank you. I will share the slides to your coordinator. You can get these slides. Thank you.
Hello, good afternoon. Can anyone give me the control to share the screen? Hello.
Hello. Sir, class not yet started. Is it there or not, sir?
No, I am here. So who's the coordinator? I didn't get a permission to share my screen.
Yeah, actually, the host is Mr. Billion and host, and other one is yeah, she's Belina is host, sir. Sir,
Okay.
please share. We are attending the class. We are ready to listen, sir.
Okay, but the problem is that I am unable to share my screen, but no problem, we'll discuss only. Okay, sir, I will not waste your time. Okay, so
Okay.
Good afternoon, everyone. Myself is Dr. Manish Jain. I am the part of technical trainer for the international team, as well as I am working as a consultant. So I am expertise in different technologies like blockchain, IoT, machine learning, data science, big data, everything. Whatever you talk, I'm expert on this. So guys, now here I'm taking a topic for NLP for predictive modeling. Okay, so the thing is that NLP is one of the portion from it. So the thing is that if you want to implement a model, if you want to create a process,